open, or? Okay, cool. So thanks for coming to the meeting, and thanks for sticking around for this. I want to talk about something that we do a lot of as engineers, academics, professionals, we don't always think a lot about, which is creating documents. Whether you're writing a lab report or a history report or a cover letter for an application for an internship, you're making documents. And a document is a way to present yourself, your ideas in written form. Very important, sometimes more important than presenting yourself well verbally, because it's a written record. It persists after you leave the room. So I want to start with a very brief anecdote from my own past. Way back when I was first out of school, fresh bachelor's degree, my first sort of serious job, and I was working on an accounting system. I was developing a system that would track disk use, CPU use by different people, different departments, tally it up, we could put limits on it. It was fairly boring. It was uninteresting to me, but it was a 3-month project I was working on. The reason I worked for this company was because they had lots of fun toys. So this was in the 80s, so they had an optical scanning system. It came with a big block of granite. It weighed a few tons to keep it stable. But if a truck went by on the beltway a mile away, you could pick it up because the image would move slightly. They had an array processor, they had a micro-coded computer. They also had a laser printer. And laser printers were not something you bought at Best Buy in the 80s. This was a $20,000 piece of equipment. Nobody knew how to use it. It didn't come with software. But a friend and I, we started at this company together, and typically we'd go home at 5, eat dinner, come back, and stay until midnight, 1 o'clock in the morning, playing with the toys. And so along the way, we wrote some drivers for this printer, and we learned how to make documents that had different fonts and things like that, something you didn't really see. So I finished my accounting package after 3 months. We just deployed the system. I had about an hour left in the day when I finished it, and I needed a break. So I'm like, I'm gonna write some documentation. And I made up a 1-page flyer that described this system, listed the basic commands, how you interact with it, and I used this printer and these fancy fonts and all that. And I printed it out. It looked cool. I put a copy on my boss's desk. I went home. Okay, what happened the next day was one of those life lessons that I never forgot. Because the next day I got into my office and there was a note saying Jack Goldman wants to see you. Now, Jack Goldman was my boss's boss. He lived on the 6th floor of the building, which we called Rug Row, because they had carpeting in the hallways. And that made them the upper muckety mucks, as opposed to the peons where I was, where we had bare floors in the hallway. So I went up to see Jack Goldman. I knocked on the door. Secretary let me in. Yeah, he can see you. I walked in. He's sitting at his desk, and there's that thing I printed out. And he's like, tell me about this. And I'm like, well, that's the accounting system we just finished. We've been working on it about 3 months. It tracks usage, blah, 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 blah. He's like, no, tell me about this. And I'm thinking I'm in trouble because I wasn't really supposed to be making documents. I was supposed to be writing code, right? Well, I thought it would be good to have a user guide, and so I summarized the commands over here. So if you want to set up some limits for a user, you can put in this option, blah, blah, blah. And he's like, no, 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 no. I don't care about the software. Anybody can write software. But being able to produce something like this, that's exceptional. How did you do this? And we proceeded to have a 45-minute discussion about this. And with a sweep of his hand, he had dismissed 3 months of this thing that I had spent 5 years getting a degree in, because he was impressed with this piece of paper. So that was a learning point for me.
Still have that piece of paper?
I don't. How many people have heard the expression, don't judge a book by its cover? Why do we have that expression? Because it's human nature to judge a book by its cover. That's how we process information. We make decisions, we make analysis, and we come to conclusions. And that happens when you hand somebody a cover letter that you produced. So I want to talk about a system called LaTeX. It's a way to produce documents. For most of us, when we want to create a document, what do? We find a PC, we open up Word, we type in our text, we boldface some keywords, we center the title, we say print, and we're done. Okay? That's not how the world always worked. So if we go back into the 70s, this gentleman is named Donald Knuth. He was a computer scientist. He trained generations of students in computer science. Brilliant man. And one of the tools in his arsenal was a textbook he wrote called The Art of Computer Programming. And this first came out in 1969, and several years later, the publisher asked for a second edition. So he made some updates to the content. He sent it in, and the publisher sent back the proofs. And when he looked at the proofs, the copy of what was going to be printed for the second book, he was horrified. They looked terrible. And the problem was the fonts that were used, the particular characters that were used in the first edition weren't available anymore. And so the publisher had substituted in a different set of characters. And it didn't look right to him. The layout was wrong, the spacing, the balance between white space and ink, it just didn't look like a polished book. And he didn't want to retypeset the book again because he knew this would happen with the third edition. And it was a very labor-intensive process. But he thought, you know, I'm a computer scientist, I deal with ones and zeros. A piece of paper with ink on it is basically ones and zeros. I should be able to do something here. So he started a small project, he figured it would take about a month, to come up with a way to use a computer to lay out a page on a piece of paper. Now, laser printers were starting to be developed. Xerox was pioneering laser printing, by the way. They were starting to be available, and he thought, can we do something like mimicking the way that books are made? So how are books made? Well, this is what your font looks like. It's boxes and boxes of these little tiny symbols. They're backwards, and they're raised metal sitting on top of like wooden blocks. And you have a little block for each possible character. And you have multiple copies of these. And you place them side by side on a line to create a sentence. And you take all those sentences and you place them in a box. And you lay them out so that the page looks aesthetically appealing. And this becomes one page of your book. You ink it, you stamp a piece of paper, you got one side of one page. And now you get a bunch of people who look like this, working hour after hour to create all these pages of a textbook. And if you got a 500-page textbook, you got 500 of these printer boxes with all these characters in there. Very, very labor-intensive, but the result is beautiful. And this was Gutenberg's revolution that changed the world in the 1600s. So Donald Knuth said, we can do this with software, and he created a system called TeX. And it was finished in the late 70s, and it later evolved into a system called LaTeX. And it was freely available software back at a time when Microsoft was starting to propose the idea of charging for software. This was free, openly available, and there were a pair of great books which Ron, who's not in here, but he had these, and he knew I was giving this talk, so he offered to loan these to me. These were the original textbooks on TeX and LaTeX.
Wow.
What was going on back in the 70s? If you had access to a computer, you were probably in a technical field because there weren't really PCs. So people weren't doing word processing and they weren't surfing the web. Basically, you were working in chemistry or physics or mathematics or something like that. You were working on a large computer that was shared by multiple people. And people were starting to connect these computers together. So a small network called ARPANET was being created. And it was 4 research institutions, and they found a way to connect their computers together. And so what you had was you had researchers who were creating high-quality documents, publication-ready documents by themselves using TeX and LaTeX. And they could collaborate with one another. So they could take these documents and they could share them with somebody at another institution before they were published. And that was kind of revolutionary. So you had better collaboration taking place, and part of why this was able to happen was because TeX, your files are very small. The documents that they produce can be very large, but because everybody had access to the software, you could share the source files, the stuff that created the beautiful document. And those were very small. You could send them over the low bandwidth communications of the early network, and then you could render them locally. And everybody would have the exact same paper as everybody else. And so this started a site called ARXIV when the web started to come online with Archie and Gopher and eventually what we think of today as the World Wide Web. Cornell started a site, ARXIV, and it was a place to upload preprints of papers before they were published. And this is still in use. And the majority of papers that are eventually published in journals and conference proceedings, they show up in here also. And these are all LaTeX files. And they upload the source and you render it. So much of the academic world is in love with LaTeX. I'm in love with LaTeX as a way to produce documents. And I want to give you a little bit of an overview of why LaTeX might be a good system to use. I want to do a bit of comparison with Word, which is what most people use, Word or OpenOffice, and just kind of So I've hit some of the highlights of this. So let me show you a pair of documents. So here's a Word document, and this is probably something that you're used to seeing, something that looks like this. There's nothing terribly startling going on here. I've got a title that's centered, I've got some equations, I've got different fonts, I've got large words, and so on and so forth. But let me show you the same document rendered with LaTeX. And it's a fundamentally different feel. It may look foreign to you. To many people, this looks very natural, though. This is what you're used to seeing in a technical publication. And there's subtle differences here. For example, in this equation, because I have this fraction over here and this triple integral over here, there's extra space between these lines compared to these lines. Is that the end of the world? No. Down here, the word effort, this F followed by this F, looks like two Fs, which it should, because there's two Fs in the word effort. But if a typesetter were to put this in a book, they would not make an F followed by an F. They would use a special symbol, which looks like two Fs, but for example, the top of the Fs meet and the crossbar meets. And it's actually a different symbol on a wooden block. And there's all kinds of cases where this happens in typesetting. And it's the difference between putting a bunch of words on a page and laying out a page. So it's personal taste to some degree which of these you prefer, and like I say, I think most of us are probably more familiar with this. I actually spent about 45 minutes on this trying to make this look as good as possible with Word.
Just the equation editor alone.
Yeah, and this I just did like straight off, all the defaults, no special changes, took about 3 or 4 minutes.
Seems like there's less white space in that one.
Yeah, so let's explore what this means. So advantages of the LaTeX system, first of all, it's completely platform independent. You have a software program called LaTeX that processes an input file and creates an output file. And it works on Unix, it works on Windows, it works on Apple. I don't think there's an Android system, but you could write one because it's all open source. So it runs anywhere, you're not bound to one particular operating system. Your input files are plain text. Worst case, if you lose your file, you've got a printout of your input, you can type it in again. You don't want to do that, but you could. If you lose the source of a .doc file, you can't, maybe you could print a binary printout of it in hex code and you could toggle that back. But it's plain text, you can email it. Emailing attachments isn't a problem now, but back a few decades ago you had to convert them into more expensive formats and so on. So it's plain text, which means it's very easy to read and it's very easy to modify. It's completely stable. It does not change over time. Now there's improvements to this over time, but the system itself is exactly the same as it always was. So this was the start of my dissertation in mathematics at Duke back in 1993. So that's 23 years ago. And I ran this off 2 days ago. Right, I had a copy of the input file sitting in an old backup, and I took that and I ran it through the 2016 version of LaTeX, and it comes out perfectly. And that's guaranteed to always happen because this doesn't change. It makes improvements to it, there's new fonts added and so on, but it doesn't break every year when a new version comes out. So stability is nice. Things like kerning, the fact that when you have a T followed by an A, you get a lot of space in here because the T extends out to here and the A begins after that character ends. That looks unnatural. It looks more natural if you bring these a little closer together and you have a separate symbol for TA or the FFs that we mentioned, which are called ligatures, being cognizant of those. Line break, spacing, hyphenation, there's a lot of work going on when you process a document with LaTeX to try to hyphenate in a reasonable way to try to control spacing. And again, none of these things is the end of the world, but the overall effect on a document, an entire page, or a collection of 50 pages, the overall effect on the reader is significantly different. You want something that flows very naturally and doesn't sort of jar the reader, and that's what LaTeX is trying to do. It's virus-free because the source files are plain text. If you could somehow write a macro that did something malicious, it would be sitting right there in the middle of your document, and it would be very easy to find.
Dumb computer.
You can have comments in your source file. Gotta have comments. It's not just for code, right? You've got a title and you're not quite sure you like this one, so you put in 2 or 3 other working titles, but you comment them out. Now they're in there and you can go back to them later, or you can leave a note saying I need to expand on this idea later, and it's part of your document, but it doesn't show up because you got it commented out. That's kind of cool. Equation formatting, that was one of the key ideas of this system, was to make it easy to do mathematical equations, and it's completely painless once you know how to do it. Bibliographies. So as you write papers for publications in journals, in conference proceedings, and so on, there's always a special set of rules for how you reference your sources. Is it last name, comma, first initial? Is it first name, space, last name? If you have 3 authors, should you say et al, or should you list them all? And that varies from one publisher to another. And in LaTeX, it's completely handled by the software. You say what style bibliography to use, and it takes care of the details. And there's a general idea of class files that basically describe things like, what should the margins be? Should I be left justified, or should I be right justified? What font should I use for the main title, for the first section headings, for subsections? Should I put spaces at the beginning of each paragraph? Should I indent paragraphs? All of that goes into a single class file. And when you're writing a paper for a conference, they will supply you with a class file for LaTeX. If it's in a technical field, almost guaranteed. And you put that in the top of your source code, and you run LaTeX on it, and it comes out the way it's supposed to. And all of this is basically built around the idea of focusing on content. Not worrying about where should I indent this, and I want a page number on the second page, but not the first. Focus on the content. That's your job as an author. Figure out what you want to say and how you want to present it, and let the software manage the details. And all of this is totally free. Freely available. You can download it, you can install it, you can use it anywhere. So this idea of content management is key, right? You focus on the content, including things like I want to boldface this word, right? Or I want to emphasize this sentence, or I want to reference this source at this point, or I want to refer to this figure. But you let the software manage the details of that. Okay, so how does this work? So LaTeX is a markup language, kind of like HTML. You put things in with your text to indicate your intentions. So if you want to boldface a piece of text, you put curly braces and you say \VF, and it makes everything inside there bold-faced. If you want to italicize, you say IT. If you want to center a section, you say begin center, put in your stuff, and then end center. If you want a bulleted list, you can begin and end an itemize and just say /item, and each thing that you put in an item comes out with a bullet next to it. Enumerate does numbers, and all of this works logically. So I can have a bulleted list, and inside there I can say itemize, and I'll start getting a numbered list. And inside item 3, I can say itemize again, and I'll start getting a sub-numbered list. And I can put a center around some part of that and center it. And it all works the way you would hope, with no quirky rules or exceptions. You can begin a section or a subsection with section and subsection. In the very beginning, I can say, here's the title of my paper, here's the author, I can put in a date, I can put in affiliations, and then when I say make title, it makes a title page using all that information. You can do comments with 2% signs. To specify a document class, you just say document class, and this is the bare minimum that you need for a LaTeX file, but this is sufficient. A document class statement, which says, do I want to write an article, do I want to write a letter, do I want to make a presentation, do I want to use IEEE transaction style, and so on. And then just begin document, end document, you put your content in the middle. And you run that through the software, and you get an output. So to process it, you say LaTeX and the name of the file, it assumes it's a TEX file, and it creates what's called a DVI, a device-independent file. And that was made when there were multiple laser printers out there and nothing was standardized. Each printer, you would write your own file to convert from a DVI. Now we can just use DVI to PDF, and we get a nice Adobe PDF file. And if you want to do bibliographies, indexes, there's other commands that you use to process those. Equations look like this. You put $ around your equation, and you can say underscore for a subscript, caret for a superscript. I can say fraction and list the numerator and the denominator. I can say limit and say what I want my limit to be. Here I'm saying x goes to infinity, and I've got a fraction 1 over x subscript n. And reading it looks a little weird, but to write it, it's pretty painless. Once you get used to it, it just sort of flows out from the equation that's in your head. Figures also work really well. So this is my biggest frustration with Word, is trying to put in figures. Because once you have figures in your document and you start adding text, everything starts to change. And a figure that you placed so carefully will like jump down to the next page, and it may occlude part of your text all of a sudden. And you try to move that down, and now your text jumps up to the previous page, and it's just, it's a nightmare. So I can say begin a figure, and this tells it suggestions for where I want it on the page. I can say try to place it at the top of the page, or try to place it right here, and so on. You can center it if you want, you don't have to. I can include my image file, in this case I'm using EPS. I can set the width of it, and it will set the width reasonably. I can put captions on there, and I can put a label on it. So my label is fig:"figure name, and then in my document I can say /ref, and it'll replace it with the number of this figure. So now if I go back and I add one more figure in the beginning, I don't have to change all the places where I said see figure 5 to say see figure 6, because this will automatically figure out this is figure 6. Yeah?
So this allows you to resize your figures?
Yes.
That's nice.
As long as your figures are produced with a vector package. And I don't have this in my talk, but here's my favorite freeware vector package of the day, Inkscape. Highly recommend it. Takes a while to learn, but does everything you would want something to do that lets you make pictures. And it's vector based, so you can rescale and things like that.
This is not pixel based?
It's not pixel based. And with most of the Office tools, you make a rectangle and you put a word inside. If you increase the size of the rectangle, either the word stays the same size, or it moves around and looks weird, and it might change from one font size to another. But this, it's all vectors, so it scales beautifully. And it does what Adobe Illustrator used to do before Illustrator got kind of bloated. So figures work seamlessly. Bibliography is the same idea. You create a file that contains all of your bibliography entries, and then you tell it what kind of bibliography you want. APA, American Psychologists Association style, Association of Computing Machinery, IEEE transactions, and so on, and it takes care of the formatting for you. And when I want to cite something, I just say \cite, and I say which thing in my bibliography I want to cite. And if that's got to get filled in with a number in brackets, or a first name, comma, initial, it'll take care of that for me. And then your bibliography file looks like this. And this looks horrible and painful to write. You can rip these out of Google Scholar. Go to Google Scholar, put in the name of your paper, the name of the authors, until you find the paper you want. Click on the Cite button, click on Others, say you want BibTech, and it gives you this. Copy and paste it in your file, you're good to go. And you only have to do that once. And if somebody wants your bibliography in a different style, you just change that one thing and say style ACM. You run LaTeX, you got your new paper. So this is all about making your life easier. All right, so let me just show you a few more examples of this, and then we'll wrap up. So here's a sample paper. This was a homework assignment for 215, so you may recognize that if you're in there. I'm saying document class article, and these are like includes in C or use in Java. I don't need most of these, I just keep them in there. I've basically got a tech document I just start with, and I just hack it up into whatever I want. But there's the title, this is the title, yay. Begin document, and then it's mostly my text, so this is gonna be a bulleted list because it's inside an itemized. I try to emphasize the word neatly because I want people to write up their homework neatly, and so on and so forth. There's some equations, so I want a 1 with a dot and a 1 exclamation for multiplication, and so on. And when I run that through, so that's a 2-page document, and this is the output. So there's the title, the date gets filled in because I didn't specify it. Write up your answers neatly. There's my bulleted list. There's my equation with things being multiplied, and so on and so forth. All right, here's a different paper. And in here, this was a conference paper that I sent in. I'm waiting for it to be rejected. If it's accepted, then somebody's crazy besides me. And this document class, I said I want to render this as an article. That's sort of the default class that you use. And I've got a title, I've got some text in there and stuff. And this is how it renders when I say article. So it's got the big title, name, affiliation, date, abstract, and then the text begins. If I change this one word up here, article, to something else, I get a totally different appearance. So if I change that to orb style, I get this. So a 2-column format. And if I change it to IEEE Tran, I get this. And it's a completely different layout from this, or this. And this is the way IEEE wants their papers submitted. And if I happen to be a student at the University of Athens, I can use the style DI thesis, which they've provided, and this will be formatted exactly the way that my dissertation or thesis needs to be formatted at that institution. And when I finish writing my 500-page dissertation and I send it to the thesis editor, they're going to look at it and hopefully say, okay, this is perfect. And you save the 3 or 4 months that you typically spend formatting your dissertation to make it match the exact format that's required. So that's a win. And a lot of people use LaTeX for doing their dissertation specifically for that reason.
Sounds pretty complex.
Oh yes. It's Donald Knuth going on behind the scenes. So last thing I wanted to show you. So here's a another paper, and this is ripped up from a larger paper that actually meant something. But down here at the end, I've got my bibliography. So bibliography paper, that's the thing that includes all those things from Google Scholar. And then I could say bibliography style, IEEE transaction, ACM, APA-like. So let me show you what happens depending on how you specify the style. So here's my paper.bib part of it, okay, the Google Scholar stuff.
A
Maybe that's all
sizable
of
part
it.
of it.
All right, and the extra command you need is just bibtech paper before you do LaTeX. And that says process the bibliography. So when I do IEEE Tran, this is what my bibliography looks like. So my citation numbers are consecutive integers and brackets, and this is ordered in order of appearance in the paper, right? And if you need to order these in order of appearance and you need to go back and add a citation on page 1, it changes the order of everything else. It changes all of these numbers. You don't want to do that by hand. So it's ordered by citation order. It's first initial, last name, and so on and so forth.
You have yourself referenced in your own bibliography.
Oh yeah.
Reference papers, he references quite a few of this stuff, previous stuff.
Someone's got it, you know. So this is ACM style, and this is alphabetized rather than in order in the paper, and it's last name, comma, first initial. And this is APA-like, which you find in a lot of social sciences. And the way you cite is by inside your square brackets, you use your name and the year of publication, and that's also alphabetized. And that's just 3 examples of different bib styles.
Changing one command.
Changing one command. All right, so there is a WYSIWYG for this, right? By itself, it's a markup language. You go into VI and just add these things in. To me, that's a good thing. But if you really want to point and click and drag and drop, there are WYSIWYGs for this. What you see is what you get, kind of interfaces. LaTeX is one of them. I don't know how you pronounce it. But LYX, again, it's free, it's portable, and it's basically a graphical front end to LaTeX. If you want documentation, feel free to just Google, but I pulled out a few, and those two seem to be pretty good. And as with most things computer related, absolute best way to learn about the system is just trial and error. Right? Get yourself an installation, put it on Ubuntu, put it on Sigma, whatever your favorite Unix setup is, and start grinding out documents, and go from there. All right, that's all I wanted to say. So that's the high level view, and thank you. And take a question.
I was actually going to say, I have another professor who uses LaTeX as well, and he has, there's a website, Share LaTeX, which means you don't even have to download the program.
Oh, cool.
And it's collaborative.
Oh, nice.
So-
Okay, sure, LaTeX. Cool.
I figured if you were going to mention it.
Yeah.
So like Google Docs kind of collaborative, only LaTeX?
I don't know it myself. He's just another professor had brought it up, so I'm going to start looking at it myself. But it looks like Google Docs collaborative, just at first glance.
It is. I used it on accident, thinking it was something else. I literally signed up for the whole thing, and I thought it was something else. But
When
yeah,
did you figure it out?
that's basically what it amounts to. It's literally LaTeX like Google Docs.
Cool.
That's fantastic.
Yeah.
Is LaTeX that one program which version gets closer to Pi?
Yes. So its version numbers go 3.1, 3.14, 3.141, and
Nice.
so on.
Oh,
It gets
dang.
closer and closer to pi.
Awesome.
Thanks. I forgot to mention that.
Okay, now it's
I love it just for that.
Didn't-
So did you show the file that, like, say, a university would give you to do the proper formatting that they want? Is that
I can show you
Sure.
one.
listed what the format is?
Oh, I forgot to show you even the best part though, which is this is made by geeks for geeks basically, right? So you find all kinds of things like a Klingon font. Right? So you got all that stuff available too.
And don't tell me, all you have to do is change one word somewhere in the file and that.
Yeah, but you gotta learn Klingon.
Yeah, it's an actual language.
Let's see if I can find one of these. I have a feeling that I stuck them in a central directory and I don't know where that might be right now.
Sure.
But it contains a bunch of LaTeX and tech macros. So there's basically a whole macro language under here that lets you define basically functions and subroutines. So there's a whole programming environment in here. And LaTeX sort of protects you from having to deal with that, but that's what's going on underneath. And when you say things like make title, it's firing up this whole program that's consuming things that you define by saying like /title and so on. And the way it does that is influenced by different variable settings. So these class files typically set values to those variables. But you can download one. I don't want to try.
But there's guides on how to
right
create
now.
one. There's
But-
guides on how to learn it too, right?
Yeah, yeah. And like I say, usually for me, I have a few documents that I just start from. And then I just go around and hack them up. And a lot of times when you're writing for a publisher, they'll send you a sample file. And you basically just delete all their text and put your text in. But it's got all the boilerplate stuff in the beginning and the end.
This is probably a given, but can you reference remote materials, like a remote file for like a remote picture, for example, or a remote one of these macro files you've described?
I don't know if you can include like a picture that's online. I've never tried.
And you're getting into HTML.
Yeah. It
Well,
ingests
it's
lots of
just
different
like
kinds.
including like a URI or something for the image link accessed by HTTP. I don't see why you couldn't.
If it doesn't support it, I suspect it's pretty easy to add that in, which makes me think somebody's probably done that.
It seems like a pretty handy
Yeah.
concept. It'd be kind of like include and then you specify a web address, which is
Right.
a terrible security problem, but
Yeah, yeah.
Virus.
But yeah, I don't see why not.
Do you think there'd be any advantage to, like, creating a plugin for Word that would utilize LaTeX in some way for a portion of the document, that'd be
That could be
an
cool.
interesting idea.
Yeah,
Like just for graph, like your,
for the figures.
yeah,
Yeah.
that kills me.
I know.
I when doing 235 technical writing, we had a huge research paper we had to do, and
One note for you, Nick, you can go ahead and put a canvas before you draw your picture, then it doesn't move.
That helps, yeah.
Yeah, you have to put a canvas and draw in the canvas, then it won't move.
Well,
Is when you put your text on the text, then it run your image on the text, then it moves.
that would have been easy if I was doing it by myself, but it was a collaborative of 4 people putting things together, and it was just a mismatch. Some people were using Google Docs, some people were using Word, and then we tried to bring it together in one,
Right, right.
it was a mess.
Yeah, and that's probably always gonna happen unless things are made to collaborate together. But yeah, my best approach I had with Word was do the text first at the end. When you're sure the text is finished, start adding in your figures from beginning to end. And then it usually worked pretty well, because it only changes things below. But once in a while, you know, you gotta review back and it's like, oh, you need to add a paragraph here. It's like, no. And literally what I would do is I would remove all the figures, I change the text and I put them back in. That ended up being the fastest way. And I'm sure that if I knew how to use Word, I'd be better with it, and a lot of these problems would go away. But I'm also sure I would have to relearn it the next year when it changes again. And I can't even copy and paste with Word anymore.
Yeah, it's different
Because there's no
options.
little edit copy option anymore. It's under home or file or something, and it moves around. And
Right click.
but I can't control V, because if I copy from a PDF and I control V, it puts in the formatting and my things become headers.
But
So I have to
Marie-
control shift V. Okay, good.
Murray, you don't copy in Vim. You don't press Control C to copy in Vim.
Right.
True. I'm finding myself accidentally using
Yeah, it's the same
Vim
thing.
commands in
Yeah.
these days, so I might as well just like commit to a format.
Right.
Just a historical background to this. These were created with people who used to write documents using VI and Emacs.
Nice.
So using command to give formatting was very natural
Right,
to these
right.
folks.
And you'll probably notice that some of the commands in VI and Emacs, like change a word or something, would fit really well with this style and not with something else.
Yep.
It looks sort of like BBC code, so I mean, if you're used to doing like web page design and all that type of coding and whatnot,
Yeah.
it should be an easy transition.
Yeah, it's markup, so.
Is there an escape character just in the edge case that you need to like?
Backslash.
Backslash, yeah. Which is escape in Unix and escape in VI, so, and escape in C. It's not a coincidence.
Skip everything.
Yeah, this is very much a programmer's mindset. That's a good point. And if you're entrenched in programming, it can start to feel